The C-CASCADES project studies the carbon transfer from land all the way down to the coastal ocean. And we're more or less really investigating at the border. We're looking at a deltaic system. And more precisely, we're looking at the Danube Delta in Romania. And the Danube Delta is the second largest river delta in Europe. And it receives water from 14 European countries. So it's a really international water, so to speak. And about 10% of the water that the Danube provides is flowing into the delta, and there is the potential to alter the signature of this water before it's actually flowing into the Black Sea. And we want to look at that and intend to do a mass balance. So how much carbon in various forms like dissolved organic carbon, particulate carbon, but also dissolved CO2 and methane concentrations, how much of that carbon is being provided by the Danube, how much is produced and how much is later released to the Black Sea. So to conduct the study we had several collaborations. The most important collaboration, I think, was the one with Cristian Teodoru, who's our Romanian collaborator. He grew up in the Delta, so he knows it very well, and he helped us to do monthly sampling campaigns in 2016. So we get like a seasonal signal of, for all the parameters we were studying. And in 2017 we changed the approach a bit and had a houseboat that was equipped with sensors. And we took those to measure continuously on our way through the delta. And for that we collaborated with Anna Canning, who's also a PhD student here at the C-CASCADES. For the third part of my thesis, we also wanted to look what the carbon sources are. So for that we're looking at the carbon isotopes, mainly C13 and C14. C13 gives us the source of the carbon and C14 as an indicator of the age of the carbon. And to be able to measure that, we collaborate with the group of Tim Eglinton at ETH. From our temporal campaign, we found that the emissions actually vary quite a lot over the years. So we have a strong seasonal cycle, which is not surprising because the dynamics of carbon is closely linked to primary production and respiration, which of course in our latitudes really depend on the season. In 2017 we had a houseboat that was equipped with sensors where we measured on our way between the different stations to see how the concentration changes actually are in between these stations, if the gradients are very steep when you go from a channel into the lake, or if it's a more gradual increase of the concentrations between the sites. The result we found is actually that you have really steep gradients in the Danube Delta, and we see a pronounced hotspot in the eastern part of the delta where CO2 and methane concentrations are really high. Our study is the first one that looks in detail into the carbon cycling into these three aquatic subsystems, so both the river segments, the channels and the lakes. And what we find is that even though the lakes have the largest surface area, the channels actually provide a lot of carbon, or the same amount of carbon to the atmosphere in form of CO2 and methane. So what we can say is it's really important, if you look at such a complex system, to really understand the spatial and temporal variability and not just go out, measure one spot and upscale that to the whole delta, because then you would miss a lot of the information and you might potentially be over or underestimating the footprint of the whole delta.